All right, thanks for tuning in again. Brandon Clayton, the Algebra Guy. And as you see on your screen, today's discussion is about exponential functions, but now we're creating a reasonable fit line when we're given data to try to make a prediction. Now, if you've tuned in to our quadratic with making predictions, you've seen this before, but now we're going to use a different function. So let's jump into it. By the end of this video, you'll be able to do this following TEK. This is the Algebra TEK 9E, right using technology, exponential functions that provide a reasonable fit to data and make predictions for real world problems. So let's jump to our first real world problems. Matter of fact, I'm gonna give you two real world problems, and then we're gonna do a couple of star problems and we'll close it up with that. So let's jump into it. Cherie invested $500 when she was younger. The table shows how her money has grown over the years. If it continues at this rate, what would be her earnings in 16 years? So she started out with 500s. And she's investing in it, and as you can see, this money's growing. This is pretty exciting. So she started with 500, and what is it going to be at 16 years? Now, on a test, you're going to be given some choices that you can make a guess. They may even give you a graph where they stop it right at 7, and you can kind of finish the graph. For instance, the graph may look something like this. So you have a graph here, and it's going up 1,540 to, it's kind of moving up like this. And you can kind of see what's going on, and it stops here. And it shows there's an arrow, but we want to know what's going to happen here at 16. So now we can make some predictions, right? If we kept this thing going about where it's going to be, we'll say about right here, and we'll try to figure out what the dollar amount on the y-axis will be. Now, so that's a good tool to get started, just to kind of say I get the idea, a ballpark figure, but we don't want to depend on that. So let me show you exactly how to do that. We're going to take out our calculators. So go ahead and get your calculator if you have a graphing calculators. And I get excited about this because they're actually asking us to use our calculator to solve this. They're expecting you to have a calculator. They're expecting you to know how to use something more than a kitchen calculator with just the 4 functions, but be able to use your graphing calculator in this way. So let's take ours out. All right, now I have my calculator. How am I going to use this? The cool thing about the graphing calculator, especially the Inspires, is they have these tools and these features down here that do a lot more than just your simple calculator. We're going to use the one here that says lists and spreadsheets. So I'm going to go ahead and open this one up, and I'm going to set up this table using columns A and B just the way they have it here. Now, instead of putting years and earnings, I'm going to just put X and Y. Now, if you really want to make it fancy, you could put earnings and years there, and it has the same effect. But for simplicity's sake, I'm just going to put it this way. Now, I'm just going to fill in my table just as they have it, 1, 2, 3, and so on, and I'll let you do the same. I'm going to jump ahead to save time on me filling this out so you don't have to watch me. So I got all my numbers put in, and I always like to double check, right? Because the calculator is going to do all the work. I just need to make sure I'm putting my numbers in right. So I got my 1, 2, 3 all the way through 7, and it looks like they're corresponding correctly. 3 with this, 4 with this one. So we just want to make sure we do that right. Now, a side note, I mentioned this before at another video, but make sure you don't leave the box here once you finish filling this one in, because it won't calculate. It won't know what number that is. So I need to press enter or find some way of getting off of that box so it can know how to calculate that point. Now from here, I want to graph these points. And there's a few ways you can do that, but I like to go back to the home screen so it's easier for me to teach this. And now instead of going to lists and spreadsheets, I'm going to go to this next one here that says data and statistics. So I'm going to click on data and statistics, and look, it gives me all these points randomly. It doesn't know how to organize them until I tell it how to do so. Sliding down here, it's going to say click to add a variable. I want to add my x's on the x-axis. Now, if you would have put in years, you would have clicked years. It would have said years here, but I just put x. So I'm going to click X, and then I'm going to click the Y, and there it is. Look, it looks like a straight line, doesn't it? So we might be tempted to evaluate it as a straight line, but we know better. So I start to see it kind of curving up here, but as we get the way exponential functions work, if you've watched them, they start off really slowly moving, but they speed up really quickly. And let's say you made a mistake and you analyze this. You went to the regression, which is what you're supposed to do, but you analyze it as a line. So here's what's going to happen. So this line is going to go through there, and they're going to give you an equation. They're going to say this is the equation for that line. Now notice it's going through those points pretty good. That's not too bad. But there's actually a better one that we want to use, and that's exponential. So I'm going to go ahead and use that one to do this. So let me instead analyze this as a, let's take this line off. Let's hide that. And let's do it instead as what we know it is, because that's our topic. But what if you didn't know? You can just do both and see which one fits it better. So, oh, that's not the right one either. Analyze, regression, and we're going to do exponential. So look how perfectly, look how beautiful that line goes through those points. So now I know that this is a better fit for these points. So I'm going to use the equation that comes from this. So look at this equation. And what I want to do is take this equation and I want to put it back into our graph and evaluate it to see how when I put a 16 here for x, what number I get. So here's the equation I have, and I'm going to write this down. And I haven't found a better way to do this other than just write it down. I wish there was a way to copy and paste it, but I haven't found that. So I'm going to write this down. Instead of writing 499.99, I can tell that this is probably a 500. And that should give me close enough to get to that right answer. 500 times 1.08. And I got 000, so it's probably good to stay 1.08. That should be good enough up to the x. Because remember, we're doing a reasonable, and it don't have to be every single digit. Now, if you want to be that precise, please, by all means, write down every single one of those numbers, and you'll be even better off. Now, what I'm going to do is go back to my calculator. I'm going to go to graph, and now I'm going to make sure I got a clear graph. Hey, let's erase this. Actually, I already have it up here. Good. So I'm going to use this here, and I'm going to press enter. And when I press enter, I don't see anything, which is fine. But what I'm looking for on the table or on the graph itself is what happens at 16, after 16 years. So let's first pull up the table, and I can do that by pressing Control T. And here's our table. So I start to see that these numbers are lining up pretty good. And if I go all the way down to 16, X is my years, so go to 16, it's easy to see that at the 16 years I have $1,712. And there's my answer. And that's it. That's really all you have to do. So what do? We use a regression line to figure out what the equation is, and then we plugged it back in to figure out that number. Now, what if you didn't know how to pull up the table or wanted to see it on the graph? You could just zoom. So let's do our zoom feature, and we're going to try to fit the data. We're going to look for it, and there it is right here. So I can kind of see it there, and actually this kind of helps me because I can kind of visualize. I'm looking at 15 right here, but I want to trace it. Here's another better way. I can trace it and do graph trace and keep pressing the cursor and finding out at the different points along that line. So I know at 9.6 is how much I have, and 10, 11, and 12, and all the way to 16, and about 16.2 we see it's about 1700. What if you wanted exactly 16? You can literally, in graph trace, that is, just press 16, 1, 6, and look what it does. It's saying, oh, you want to know where x is equal to 16. And I'm saying, yes, I'm going to press enter, and it goes straight to 16, and there again was my answer. So pretty strong stuff you can do using a calculator. Let's go to our next problem. So our next one is similar. The wonderful world has been seeing a dramatic shift in its population in 2000. Given the data in the table, what population prediction can be made for the year 2023? So in the year 20,000, they've been seeing a great shift. Something's going on. Now look at the data here, and these are the years after 2000. So this is 2009, 2014, 2006. It's kind of tough to make a prediction visually, isn't it? Because the data is so jumbled and scattered. And they're going to do this sometimes as well because they want to know that you're not trying to just guess, but going to actually use a calculator to let it do all the work. So let's just do that. We're going to go back to our calculator, and I'm going to make sure I get a new screen here. I'm going to go to Document and do New, just to make sure they give me a new. I want to erase out the data because sometimes if you leave that data there that you recently had, see, I have these 1.1, 1.2. It has a difficult time knowing which data you're talking about. So I'm gonna erase everything. I'm gonna say no, I don't want any of that. Now I'm gonna go to a new one. Now I got a brand new one, and we're gonna put this information in. So we're gonna do X and Y as we did before, and start to put everything in here. All right, so now I got all my information in here, and we can kind of visually compare it. So I try to do exactly the way they did it. Now, we don't know if this is increasing or decreasing at this point. They just said it's a dramatic shift. So we definitely want to see what this looks like. So let's go back to our home, and we're going to go to data and statistics, and it's all jumbled up as usual, but we're going to order it by pressing X on the bottom and Y here. And now look at what's going on. Oh, now we get a good idea to see that it must have started out with a lot of people and it's been drastically declining. Now, what kind of graph does that look like? We got three graphs to choose from, right? A line, a quadratic, or an exponential. Well, we already know the answer, right? This is exponential conversation, and it's not a U-shaped. It's just starting high and it's coming down drastically here, but you don't see any kind of U shape going on, and it doesn't seem it's going to pick up at any time soon. So we're definitely going to use an exponential regression to analyze this. So let's analyze this regression, exponential, and there it is. See how well that fits. Now this is the equation we're wanting to take before we can figure out what's going on in 23. So 23 years later. So I'm going to write this one down, and we're going to keep this equation. So let's write that one down. Got everything written down here. It's a pretty big number. How big is this number? This is, let's put our commas, 275,874. So they started off as a pretty big population, and it's been declining, as we can see, because this is less than 1, right? Between 0 and 1. And you see I didn't write down every single number, but I did do a couple of decimals here afterwards, and this was all zeros for the most part, so you can just keep that 0.8. Now again, if you want to write down every one of them, you'll be completely fine as well. So I'm going to take this and we're going to put that in the calculator under graph, and we're going to make sure we got a clean graph. As you see, I put my number in, fresh screen, no other graphs here, 275,000, and we're going to press enter, and we're going to evaluate. We're going to figure out what happens when X is 23. So once we put it in like this, it becomes real easy. So what's the problem? Why is they giving me a problem? Because they don't like me to have commas. So let's press enter there. The graph disappears because it's way too big, right? It's way up there somewhere. But I can just go to the table, Control T, and if I scroll down where X is 23, my answer becomes clear, 1,628, and I'm done. That's really all I need to do. I'll look at my answer choices and it'll be pretty clear that that's the only one that's even close. You could have looked at it on the graph as well. So if I would have went back to my graph, I could have gone to graph trace, and graph trace, and if I would have just typed in 23 and pressed enter, it'll tell me at 23 it's going to be 1628. So I got a verification from two different places. So that's two ways that you can get your answer there. All right, let's go to our star problems. We want to look at how did it look on the star test. Actually, you know what? I may need that, but we'll look at it from here. So here's one question. This question, 88% of people got right. It was pretty simple to figure out. A factory began producing new parts. Data was collected on the number of defective parts per 10,000 parts produced. The graph shown displays some of the data for the first 10 weeks of production. Based on the graph, during which week were approximately 130 defective parts per 10,000 produced? About 130. Let's see. So that should be pretty easy. So let's get a line. 130 is right here. So at what point would that line have crossed? So if I'm going to sketch what this graph looks like, and this is why a lot of people got it right just using common sense. If we were to sketch and just connect all these dots, man, I'm not doing a good job connecting those dots. So we can get an idea of how the line's going to go. So we see it's going to cross about right here. And that's at about, what number is this? If I go all the way down, we have 5 weeks. So we can see that it's going to be week 5. So pretty easy there. Not a big deal. Now the next problem is more similar to the one that we've been talking about. And this is why only half of the individuals who've taken this, 53% only got this right. But you're going to be different. You're going to get 100% because you're going to get this right. Because they did exactly what we talked about. They gave you a table all the way up to 35 years and then asked you what happens after 40 years. What happens in year 40? So we know it's going to be bigger than 539, so which all of these are. And we can kind of get an idea if we kept this line moving, you know, somewhere around here, maybe something like that. But again, we don't want to guess. We're actually going to do the math to figure out exactly where this is. So let's take out our calculators again and do this problem. So let's go to our table. We're going to put our X and Y in again. X here, Y here, and I'm just going to fill in everything as I've done before. All right, so now I've input all of my data, and I'm kind of glance over, make sure it looks good, and it looks good to me. So now I'm going to go to data statistics, click here for my X, click the Y-axis and press Y, and there's my exponential graph. So I know exactly which one to pick. I'm going to use analyze regression for a exponential, and here's the equation I want to use in order to write this. So I'm going to write that equation now. All right, so now I got my equation written down so I remember. I'm going to go back to my graph and put this calculation in. And now that my equation is in, I want to see what this looks like on the table. So I'm going to go to table and do a split screen, and I'm curious what's going to happen at 40. So actually, before I even do that, I'm going to see if my numbers are lining up to what theirs are as it should be on the table. So at 0, 36, 50, 500, so that's about pretty close, 8 off. At 5, we have 53,000, good. And I'm gonna skip all the way down to 30, make sure I'm on the right track. At 30, I'm at 367, 208, so that looks good. So now at 40, look at this. At 40, my number's so big it's not fitting in there. So 792,775. And if I hover over it, I can see what the whole number is here. And there's a way you can expand this a little bit if you really want to see that number. So 792,775, and the closest to that, as you can see, is going to be answer choice D. Now it's kind of cut off, but it's going to be 800,000 kilometers squared. So that's our correct answer choice. And again, you could use the graph and do a graph trace and figure out that way as well. But I don't want to be redundant in showing you that again. But it's really easy to do. Graph trace, graph trace. And if I just press 40 and enter, then I'll see at 40 is 7.92. And this E, by the way, stands for times 10 to the 5th power. So if you remember how to use scientific notation, this is like a bonus here. 7.92 times 10 to the 5th power. They're just saying move that decimal 5 places to the right. 1, 2, 3, 4, 5. And you'll add your zeros there, and you'll see what that number should be. It's going to be the same as ours. So I think that does it for us today. Let's go back to our screen. Yep. Right, using technology, exponential functions to provide a reasonable fit data to make predictions in real world problems. We did exactly that. Thank you for tuning in to the end. My name is Clayton, the Algebra Guy, and I will see you next lesson.